Alright, gang, today is Wednesday, April 22nd, which means that it is real life Orgo. But before we get started, let's think about what we have to do. We have a quiz on Friday, so I'll announce those problems at the end of this. And we have a problem set due on Monday, so make sure that we're working on that right now, get that in soon. But today is a really fun real life Orgo. We are talking about methamphetamine and Adderall. We're going to be looking at the differences and similarities and the structures and the effects. So, in the standard synthesis of methamphetamine, we have ephedrine or pseudoephedrine reacting with hydroiodic acid to give us our methamphetamine. And we can get our ephedrine or pseudoephedrine from over the counter cold medicines, which is why they are so regulated and highly watched by the DEA. So, you can get that by just extracting it with water or alcohol, and we can get our hydroiodic acid from iodine crystals, which are in disinfectants, and react that with red phosphorus, which you can get from matchbooks or flares. And so the pseudoephedrine undergoes a nucleophilic substitution reaction with that iodine, and it knocks out that hydroxy group to give us our intermediate product, which is then further reduced down to give us our methamphetamine. But since ephedrine is highly watched and highly regulated, another method that people have used is with phenylacetone or P2P. And that reacts with methylamine, which is another substance that is regulated by the DEA to give us our methamphetamine. So we can get our phenylacetone from a reaction with phenylacetic acid and acetic acid, which is catalyzed with thorium dioxide in a heated tube furnace to give us our P2P. And so when our P2P is reacted with our methylamine, it forms a Schiff base, and then that Schiff base is reduced with mercury aluminum amalgam to reduce it down to methamphetamine. Another popular reducing agent was, not anymore, was palladium dioxide. It is highly explosive, which is what was causing all of those lab blowups. So that reaction gives us a racemic mixture of methamphetamine, the two isomers, the D and the L, and the standard synthesis gives us a higher concentration of that D product, and that D product is the strong stimulant, that classic drug effect, while the L isomer is a weaker stimulant, so it's used in medicine, so it will still keep you up, which is why some drugs, they don't want you taking them late at night because it has that stimulant effect to it. But another quality that Breaking Bad was known for was their blue meth, and that blue color would have only been caused by a blue impurity in the reaction, which is highly unlikely. So people will kind of assume that it was food coloring or some other coloring effect to give it that blue color, which would not come naturally from any chemical reaction. But I'm running out of time on this video, so we're going to pick it up on the next one.
So now we're going to talk about the synthesis of Adderall. A precursor to Adderall was synthesized in 1887 by Lazar Adonliu, which was a Romanian scientist. And so he had done all this research and produced this drug, but he didn't really study its effects on the human body, so a lot of his research was buried by other scientific journals. Later, in 1929, Gordon Allais recovered this information and built upon its synthesis to create the new common product, Adderall. This product was marketed as an antidepressant and became an over-the-counter drug in 1933, and it was available in many pharmacies. And this product was introduced by SKF, which was SmithKline in French, which was a big pharmaceutical company at the time. And so to make up this Adderall product, it is made of the 4 salts of amphetamine, so there's 25% of each in Adderall. So the 4 salts are dextroamphetamine saccharate, amphetamine aspartate, dextroamphetamine sulfate, and amphetamine sulfate. And its common IUPAC name is 1-phenylpropan-2-amine. So there are 6 different ways that you can create Adderall. The most common and used in industry and for illegal activities is the Lukert reaction. So what happens is phenylacetone and formamide, or it could be formic acid, either one works, are combined to create N-formylamphetamine. So that is the intermediate in this whole reaction. That intermediate is then hydrolyzed by hydrochloric acid, and then that product is extracted with organic solvent. This creates the free base. And then that free base is taken and dissolved in a different organic solvent, and sulfuric acid is then added. From this last reaction, amphetamine is precipitated and is the crude product. And of course, it'll go through some crystallization just to refine the process. But that's the main way that industry uses to create Adderall. And so there are a couple other reactions that we can use to create Adderall. And one of them we talked about in class is the Friedel-Crafts alkylation. Another one is the Ritter synthesis that we didn't really go into depth on. Another one is synthesis via Hoffman and Curtius rearrangement. So there's 2 different ways you can do it in that synthesis. There's another one by Noen-Venegal, condensation, that can be used. And then there is a synthesis using phenylacetone and ammonia. Now, many industries won't use the last 2 because it uses LEH. And we know that LEH reduces your pet dog and your grandma. So those are very dangerous materials and they're not used in industry. So next, we're going to go and talk about similarities and differences of Adderall and meth.
So on the left, you can see the generic structure of a phenethylamine because it has the phenyl ring, the ethyl carbon chain 2 carbons, then the terminal amine. And you can see the carbons are labeled alpha, beta, etc. And when you add a methyl group on the position of the alpha carbon, you get alpha methyl phenethylamine. You can see the letters highlighted in yellow. They make up the word amphetamine. That's where it comes from. And if you add an additional methyl group to the hydrogen, you get methamphetamine. And both of these compounds present stereochemistry. They have enantiomers, only the orientation of the methyl group changes, so they are non-superimposable mirror images. You can see for levoamphetamine, dextroamphetamine, and the same we have L-methamphetamine and D-methamphetamine. We notice some differences in the infrared spectra. As you can see, the peak around 3,400 centimeters on amphetamine, that signals a primary amine, which only the amphetamine has because methamphetamine is the nitrogen is connected to two carbons. And we can also see the other peak around 1,600 centimeters, which signals NH bending, and we are going to have more of that in the amphetamine because it has two NH bonds rather than just one. With regards to hazards, amphetamine presents all the hazards that methamphetamine presents, as you can see in the Venn diagram, but it also has a lot of additional hazards which are related to fire, sparks, flammability, and we are going to see why this is. As you can see, only amphetamine presents the flammability warning, and even though both compounds have a similar amount of carbons, which are oxidizable, the differentiating factor is actually what we call topological polar surface area, which refers only to polar atoms and the hydrogens that are connected to them, only that surface area. And as you can see, amphetamine has a much larger area because the nitrogen is not shielded by the methyl group. So you can think about this as what is going to burn faster and stronger, a big chunk of wood or a bunch of little sticks of the same mass. And it's going to be the sticks because there is a lot more area that's contacting the oxygen, and therefore a lot more opportunity for oxidization and combustion to happen. So fun fact, well actually not so fun, when we burn nitrogen we get nitric oxide, NO. This is a greenhouse gas which will further oxidize in the presence of sunlight and become NO2 and other gases. So we just group it together as NOx, that's how we label it, because it is hard to define a set amount of each compound. Now obviously your employer or your sports league doesn't want these drugs in your system, so let's talk about some ways that they can be identified in your urine, saliva, bloodstream, etc. One common way to do this is acetalizing the amphetamine with trifluoroacetic anhydride in this acid-catalyzed reaction, and it involves the lone pair on the nitrogen attacking the carbonyl and a lot of other stuff that you have learned, and the acid being regenerated at the end of the reaction. We can then determine whether amphetamines are present by looking at retention times with a gas chromatography, where we have a principle similar to that of TLC because we have a mobile phase and a stationary phase. The mobile phase is the carrier gas, which is usually helium. Because it is a noble gas, it has a full valence shell, so it is generally unreactive, so it will not cause problems with whatever sample we inject into the machine. Finally, you can have your final moments if you consume too much of either of these drugs, and actually contrary to what many people believe, amphetamine is much deadlier than methamphetamine. You only need 2.2 milligrams per kilograms to die. That's the lowest lethal dose. And obviously we are not conducting these experiments on humans. These are just reports from people who came into the hospital with the drug in their bloodstream and later died.
In this segment, we're going to be looking at the effects of meth and Adderall. We'll be talking about both Adderall and meth in the context of ADHD because both Adderall and meth are approved treatments for this disorder. Stimulants like Adderall help by increasing the release of certain neurotransmitters like dopamine and norepinephrine. They also block or slow down how much of these chemicals is reabsorbed back into the original neuron. Even though it is not yet exactly understood, we know that Adderall plays an important role in the efficiency of dopamine neurotransmission. Amphetamine, which is the stereoisomer of dextroamphetamine, is known for releasing dopamine, while dextroamphetamine is known to be a reuptake inhibitor because it is a substrate analog, therefore it competes for uptake with neurotransmitters such as dopamine, serotonin, and norepinephrine. Now, are there side effects? Yes, 100%. As with every medication, there is a long list of side effects, and some of these side effects include headache, stomachache, trouble sleeping, a decreased appetite, nervousness, dizziness, mood swings, weight loss, dry mouth, and fast heartbeat. However, these side effects are to be expected from a stimulant, and these are the common side effects. In addition, Adderall has interactions with various medications, including antihistamines, tricyclic antidepressants, and most notably, monoamine oxidase inhibitors, as they will have a potentiating effect on the amphetamines. Treatment is generally not approved for use in patients with cardiovascular conditions or a history of drug abuse, and it is prescribed in both an extended release and immediate release form, in both generic and named brand, for the treatment of ADHD, attention deficit hyperactivity disorder, and narcolepsy, which is a sleep disorder characterized by excessive daytime drowsiness. The extended release form may be effective for 7 to 10 hours, while the immediate release form may be effective for 4 to 6 hours, and patients will commonly take divided doses throughout the day. Now, is there potential for abuse? Yes, there is a high potential for abuse. Adderall is popular among students and young professionals because it is rumored to enhance alertness and productivity. However, in someone without ADHD, Adderall will give an effect similar to that jittery feeling that you get after drinking too much coffee. Adderall use in a person without ADHD results in an excess amount of dopamine being released into the brain, a high feeling, feelings of boosted energy and intense invigoration, and feelings of euphoria. Now, it is a Schedule II controlled substance because of the high potential for abuse. Prolonged administration will lead to dependence because it causes the brain to produce, absorb, and transmit less dopamine, serotonin, and norepinephrine, and your brain builds a tolerance, so abruptly stopping after prolonged use can result in extreme fatigue and depression. As far as overdose, the misuse of amphetamines may cause sudden death and serious cardiovascular adverse reactions. Now, on to meth. Is there a prescription version of meth, you might ask? Yes, actually, there is. The brand name version is called Disoxin, and the generic name is methamphetamine hydrochloride, and it is used to treat ADHD and exogenous obesity, for which it is used only on a short-term basis. However, what is the commonly known meth? The meth that we are all used to hearing about, and the one that we will be discussing today, is crystal methamphetamine. Yes, Q. Walter White. It is used by smoking it, swallowing a pill, snorting it, or injecting the powder that has been dissolved in water or alcohol. And it works by increasing the amount of dopamine in the brain, and its ability to rapidly release high levels of dopamine in reward areas of the brain strongly reinforces the drug-taking behavior and making the user want to repeat the experience. The short-term side effects include increased wakefulness and physical activity, decreased appetite, faster breathing, rapid and/or irregular heartbeat, and increased blood pressure and body temperature. The long-term side effects are pretty serious. In terms of drug equipment, there is a risk of contracting infectious diseases such as HIV, hepatitis B, and hepatitis C. Also, meth may worsen the progression of HIV or AIDS and its consequences. There will be more injury to the nerve cells and more cognitive problems as a result. Other side effects include extreme weight loss, addiction, severe dental problems termed meth mouth, intense itching leading to skin sores from scratching, anxiety, changes in brain structure and function, confusion, memory loss, sleeping problems, violent behavior, paranoia, hallucinations, reduced coordination, impaired verbal learning, severe changes in emotion and memory, and increased risk of developing Parkinson's. There is high potential for abuse, as withdrawal symptoms include anxiety, fatigue, severe depression, psychosis, and intense drug cravings. Overdose occurs when a person uses too much of it and has a toxic reaction, which often leads to stroke, heart attack, or organ problems. Were we to assume side effects and contraindications, we would assume that they would be similar to those associated with Adderall due to the similarity in chemical structure. But as far as other interactions go, street meth is illegal and widely variable depending on the lab synthesis method and mixing of other substances in terms of pure product or laced product. This can mean that either the meth will have intensified effects or it is cut with potentially dangerous additive that will increase profit for a street pharmacist. As a result of the impossibility of regulation, no conclusive studies have been done on street meth and no generalized information is available except that it is bad.